Okay, so let's talk about AI. These large language models, right? They're incredible. They can write code, they can write poetry, they can answer pretty much anything you ask. But there's this weird catch. For all the stuff they seem to know, they also have this really strange habit of just making things up. We call it hallucination, and it kind of throws a wrench in the whole can we trust this thing debate.
So, that brings us to the big question for today. Do these AI models have any clue when they're feeding us bad information? Is there some kind of internal tell, a signal inside their neural networks that basically screams, hey, warning, I'm about to pull this next answer out of thin air? Can we build an AI lie detector?
You know, it's a really popular idea in AI research. This thought that maybe the secret isn't in what the AI says, but in how it thinks. The theory is, if we could just peek inside the AI's brain while it's working, we could spot the difference between when it's confident about a fact and when it's just bluffing. But, as we're about to find out, it's way more complicated than that.
All right, so to really get to the bottom of this mystery, we first have to understand a crucial detail. Not all AI lies are created equal. It turns out these hallucinations come in a couple of different flavors, and telling them apart is the key to cracking this whole case.
So researchers broke it all down into three kinds of answers. First up, you've got the factual association, or FA. That's the right answer. Easy enough. Ask where Obama was born, it says Honolulu, perfect. Then, at the complete other end, there's the unassociated hallucination, or UH. This is just a totally bizarre, out-of-left-field lie, like saying he was born in Tokyo. But the one in the middle, that's the real problem child. It's called the associated hallucination, or AH. And this is a lie that sounds believable, like saying Obama was born in Chicago. It's wrong, but he's so connected to Chicago that it feels plausible.
Let's really drill down on this one, because this is the sneaky villain of our story. An associated hallucination is what happens when the AI gets tripped up by all the statistical connections in its data. It's seen Barack Obama and Chicago in the same sentences millions of times, so it creates this strong, plausible, but totally wrong link. This is by far the most common and the most dangerous kind of error these models make.
So how in the world did scientists figure this out? Well, this is where it gets really cool. They didn't just look at the final answers. They did what's called a causal analysis. You can think of it like they're tracing the path of a thought as it travels through the AI's digital brain, watching to see exactly where a right idea turns into a wrong one. And they put three specific internal signals under the microscope. First, subject representations. Basically, what does the internal concept of Barack Obama even look like inside the network? Second, attention flow. How does that Obama concept guide the AI toward the final word of its answer? And third, the last token representations. This is like a snapshot of the AI's mind in the final millisecond right before it spits out the word Honolulu or Chicago.
Now check this out. This chart is our first major clue. When the researchers asked the AI about obscure, unpopular topics, that first bar on the left, a massive 94% of its mistakes were those wild, totally bizarre, unassociated hallucinations, the Tokyo kind of lies. But when they asked about popular subjects, the whole game changes. The AI is much more likely to be correct at 66%, or to make one of those tricky, plausible, associated hallucinations at 14%. And this is a huge insight. The type of lie the AI tells depends on how well it knows the subject.
And this leads us to the first absolute bombshell of the investigation. When the researchers traced all those internal signals, they found something mind-boggling. The flow of information inside the AI's head, the whole process, looked just as strong, just as confident when it was telling a plausible lie as when it was telling the actual truth.
So, this is the moment. This is where all the clues come together, and the investigation leads to a conclusion that really shakes up one of our biggest hopes for making AI more trustworthy.
So think about it. If the internal process looks just as strong for a fact as it does for a plausible lie, what does the AI's brain scan actually show us when we compare the two?
They're almost identical. There's no internal warning sign, no flashing red light, no lie signal whatsoever. The AI isn't deciding to lie. It's just following the strongest statistical path it can find. And when it comes to these plausible lies, that path looks exactly the same as the path to the truth. And this visual just drives the point home perfectly. If you were to map out all the AI's internal thoughts, you'd see the bizarre lies, the unassociated ones, are way off in their own little group. They stick out like a sore thumb. But the correct facts and the plausible lies, they're all mixed together in one big, indistinguishable blob.
Just by looking inside the AI's mind, you can't tell them apart.
Okay, so this isn't just some weird academic discovery. This has huge, real-world consequences for how we build and, more importantly, how we trust these AI systems. Let's really unpack why this is such a big deal.
Just look at the hard numbers in this table. This score, the AUROC score, is basically a grade for our lie detector. 1 is a perfect A+, 0.5 is a total F. It's just guessing. Now look at the results. When it comes to spotting the bizarre lies, our detector gets an A. It's scoring above 0.9. Awesome. But for the plausible lies, the ones that matter most, the performance totally tanks. A score of 0.58? That's basically a D-. Our lie detector is broken for the most common and dangerous errors.
And this leaves us with 3 huge takeaways. First, our current methods for detecting lies are looking for the wrong thing. They're built to spot how confidently the AI is recalling information, but confidence does not equal truth. Second, that whole idea of training an AI to just say, "I don't know," it doesn't really work for these plausible lies because the AI has no consistent internal signal to learn from. And third, and this is the big one, we cannot rely on the AI to police itself. If we want to know if it's telling the truth, we have to look outside the model, using external fact-checkers and search tools.
This quote from the researchers just nails it. Large language models do not encode truthfulness, but only patterns of knowledge recall. It's a machine built to recognize and repeat patterns, not to understand the concept of what is objectively true. It's a know-it-all that doesn't actually know. It's a pretty wild conclusion, isn't it? And honestly, this is exactly the kind of stuff we love digging into.
So if you're into deep dives that get straight to the point and feel more like a vibe than a boring lecture, then go ahead and smash that subscribe button for VibeDoc. We work hard to check our sources, so we promise not to hallucinate, probably. So we'll leave you with this last thing to think about. If the very way these AIs are built makes it impossible for them to know the difference between a fact and a really convincing lie, what does that actually mean for the future of artificial intelligence? That's a question we're all going to have to figure out. Thanks for tuning in.